Hi everyone, welcome back to Simpit Academy channel. Today we continue on the right console and we look at the environment and the light control panel. So for a start, the environment includes this oxygen regulator. In the past I've used just flat handle toggles for this, and I saw that this guy Michael Hirzy shared this on a Facebook group. So um, Romeo Kilo, from Warthog Project also shared his version where he used like magnets, and I like this one more. It's easier. Um, you have things below. Anyway, here is the link on Maker World, and you can download. And these are the various parts. Okay, one change is that this one he made a potentiometer here, and this handle is bigger than the other two. These two are identical. The way I do it is I print this 3 times and use it all throughout, and I remove this and I put a toggle here, right, like the other two. So all toggles, all the same handles, because in DCS is also a toggle, not a part, and it's just easier. All right, so you have a lot of mini toggles. Um, let's take a look. So if you open up in FreeCAD, you will see actually many other stuff that I've hidden the view just to show the key ones. This is the top panel, which he calls the light panel. Then there is a back plate, right, which is this guy here. And then there is a rotation plate and there is a switch plate. Okay. Then all this optional stuff here. So you want to find the key, the right ones and print. So this is the light plate, the back plate. This is the rotation plate and the switch plate, right? And here we are not using this, and we cover this and put a toggle here. And then what this means is you need to put a piece of rod or hard wire, something, to hang this handle, right? You put this through this first, and then through this handle, and then continue through again, and then come out here. And this tends to slip as well. So if it's not tight fit, then you want to glue the sides to block it from falling out. All right. So the top panel, we need to add text, but I don't know why I keep getting error when I try to edit this. So instead, I just printed this base, a very thin 0.5 mm layer, and then I added all this text um, to it. Okay. So as I said, I'm not using this. This is to hold the part. I After I printed this, I realized I'm not going to do this, and I just sawed this away. And then I added this thing here, the base, to hold it to this, and then this thing is to the size as same as this to hold the mini toggle. So this optional stuff, this one is called test port small and big. Then you want to print the needle for the gauge, and you want to print this 3 times, okay? And this toggle top thing 3 times. So for the oxygen panel, the PDF that was provided by Romeo Kilo also has this thing here. So you want to first create a base and reverse pad it, okay, for the text to sit on, then just print out this whole thing. Okay, you also want to print this to hold the needle. So, okay, these are the optional things. I also added this thing. You just glue this. This one I didn't put like a piece of glass over it. You can do it, and then here I just covered with a white plastic. These two are not functional, right? So if you want to put an LCD screen or mechanical stuff, it's up to you. I just didn't bother to do this. Now these two, they are printed black, and then here I just spray paint with metallic looking light paint, and then add a screw. Okay, so you see here the three handles, the three toggles, and this is the toggle top, right? The toggle top has another piece of rod over here. So this one is three-way, two-way, two-way. This one three-way, but this side here it's momentary, which means that the toggle, the up position is momentary, it's opposite, right? When you press this down, it pushes the toggle lever up. So momentary, off and on. So I had a piece of nail. I just cut it into half. Half goes here, half goes here, and then this part here, the ends, and this part here, I just add some hot glue so it doesn't the nail doesn't fall out. Okay, and also added some glue here. So things tend to be a bit loose. So just glue all this, and then this screw, um his design, he had this metal spacer thing which I don't have, and I found that this screw I had at home, 2-inch long all the way to the top. Okay, hold everything together, the switch plate, rotation plate, back plate, light plate, everything together, and it's tight enough such that this thing will not fall down. I don't need like a nut to hold this up. Okay, so you want to be careful because don't um don't drill in too much such that it breaks into the surface here. Okay, and we have the code, very simple, right? Two-way only has one pin, and then the three-way has two pin. Next, we look at the environment panel, the rest. So this is the back panel. As usual, bring from the PDF, convert to SVG in Inkscape, and bring it in here, select. Okay, first select all this light, which I'm not using, um, and delete them. Okay, if you are doing backlighting, that is. So then you are left with all this. You want to select the cutout, the panel cutout, and select all these holes for screws, for toggles, whatever. So start adjusting. As usual, the outer ones are the bigger 4.3 mm for the hex screws. The smaller ones inside are all, like you see all this here, the 3.6. Okay, Then determine what size of toggles you are using, the big ones or the mini ones. So this size is fine, I keep this. Then at the bottom, you want to add recess for the body of the toggles to sit further in, right? And then um, actually it's more for the locking plate, okay, with the hole, and you want to push it in. If you just have the hole, it will still work to hold the toggle, but if you have the whole lock ring, sit in flush, then um, it will hold the toggle better. So top panel, when you have a like a vertical slot like this, it usually means that this is a three-way toggle, and then the fully round ones are two-way toggles. Okay, these are potentiometers or encoders, right? And this one here as well. Now this one is a special toggle up, down, left, right, but actually the left, right are not functional, so you just use a toggle, up, down will do. So then the back recess for the toggles, sorry, for the nut of the toggles, right? All of them have recess. Now you see this text keep appearing by itself. So I mentioned in my other videos before, whenever you have the word RA, okay, this one rain remove RA, somehow when they are together, you won't be able to pad the text. So I will have to separate them or use the extrude button in the part workbench, okay, to extrude the text. So some more recess for the toggle, and then the lines. These are all already drawn in the PDF. You just have to select them and pad. Okay, so this one is an opening. I actually created like a semicircle thing and cover this. Um, and this is a top recess. Now for this bottom here, you have two disc, right? Which again is all provided for. You want to make sure the width, the diameter is big enough for your toggle. So this is I'm using encoder. And then just pad this. Um, okay, text is 1 mm, but this thing is about 3 mm. Okay, so do the same for the other disc. The text is slightly different. Now for the gauges, as shown in my F-15 Strike Eagle videos, this free tool is very powerful, very easy to use to create gauges for any aircraft. Okay, I've used it for the F-15, now we use it for the A-10, you can use it for F-15, F-4, whatever. So here we start at minus 180 like this, and then we end at 300, which is um, around here, the length. So this is like 270, right? 300, 360. So how how much do you keep going. Then primary is all the big ones, and then secondary smaller ones, and then these are the tertiaries. Okay, determine how many, determine the thickness that you want to appear, and then save as a PNG. If you save as SVG directly and import into FreeCAD, it will not work. So you have to do an extra step. You have to save as PNG, just like the PDFs. Then go to Inkscape. Okay. Um, in Trace Bitmap, select the edge detection and reduce the default 0.65 down to 0.1. So it's final detection. Click on this thing and it select all this. Okay. Then click on export and export as SVG. Then in FreeCAD you import the SVG. Okay. Now you don't want to select everything because it has two lines. It has an outer line and the inner line. The inner line is shown here. Okay. The green line. You don't want to select the green line. So you want to skip all these that are the inner lines. What is shown here is the outer line. Okay. Select the outer lines and then click on this one here in draft workbench. Click on the scale, and before you enter anything, click on this enter point first. Okay. Then reduce it by a third. So then you get this smaller one. Okay. Next you want to hide the big one. So you select this, hide this. Then now we have the smaller one. That is 1/3 the original size, and you click on this one in draft, and this will create a sketch, right? As usual, after you select a sketch, you actually have to create a body and move the sketch into the body. So here, you want to create a circle and move the circle to the same place as this scale here and reverse pad it to give it a foundation to sit on. Okay, you cannot just pad the scale as is. It always need to sit on something. So you reverse pad, give it a base, and then select the scale. Okay, this is the size of the circle, right? Slightly bigger than the scale. Then you see the scale, the base, I reverse pad it down. Then you can highlight this scale thing and pad it up, right? Then this thing I add another circle, okay, to put behind um behind the back panel so that this thing won't fall out, right? Then you just glue this thing. Okay, then we add text. So you also want to increase this, draw a bigger circle, um, like this, and then have the text. Okay, my texts are bigger than usual. Anytime you emboss text, it cannot be too small. Anything smaller than 3.5 size font becomes very hard to write over with a white marker. So I deliberately make things bigger. Okay. So next we need a needle, right? So the needle basically is like this. Okay. Um, this one it's just slightly thicker. Usually I pad things like 1 mm. This one I just add 0.5 mm, and the bottom is hollow, right? To sit over this thing here, and it's a tight fit, not so tight that it cannot rotate, right? Well, it's for show anyway. So you put over this and you paint this white and you're done because the needle is black. All you want to see is the white part. Okay. Now for the second gauge, again we use this gauge maker tool, and you see here we start here minus 90, right? Here is 0, go minus 90, and then we go for how long? 180. So 180 like this, right? If you start here, this is 90. So minus 90 to 90 is 180, and then we have 5 primary, and then um, I think the minimum is 2. So anyway, these are the secondary, these are the tertiaries. Again, play with the thickness that you like, and again select the outer ones and ignore the inner ones, or delete or hide the inner ones. Okay, add text. Before that you need to create a base, reverse pad, put the text on top, pad the text, add another base, then it looks like this. So now for the gauge needle, so this one is only one side, so have this circle and pat this down, hollow, right, at this part here, like the previous one. So this part is white. All right, so fits on tip on top like this, and now you have the completed one. Now this is optional. This one I didn't even 3D print it, just forgot about it. So here you just have like a plate with L brackets, um, the canopy disengaged. So I bend a piece of metal, um, and have a, this is a, like a glass acrylic ball, right? Drill drill a slot and then stick this thing uh inside, paint it, spray paint it yellow, and you're done. So I have I have two micro switch here. You need to wire one of them. Once you push it out, right? This one is just to stop it from going any further. Actually, this will stop it too. So to rotate, you put it around this screw, and this one you once press, it goes down like this. All right. And we have the DCS BIOS code. So this is the code for the disengage lever. Then the rest here. You see this when it says no function, um so it's not working, and then therefore you can skip the wiring. Of course, if you wire, you can still see it turn in the game, but since it doesn't do anything, I didn't bother wiring them at all. It also save you some pin. So for this one, um since these two are not working, you can don't assign any real pins. So I assign 0 and 1, which in Arduino doesn't work. So yeah, again, save you 2 pins here. All right. So I've changed all the parts to encoders. Parts give a lot of noise. They are analog and they generate a lot of noise in Arduino. If you use Leo Partner, I heard that it's much better for parts. But Leo Partner, some people love it. It's cool, it's easy to use, and it's you don't have to run DCS BIOS, right? But in terms of cost per pin, it's a few times, about 5, 6 times more expensive, right? It's like $70 with, I don't know, 50 pins. What? So the Arduino is like $12. So backplate, for the light control. So this is like the electrical panel, just toggles and encoders, very straightforward. You have two slots here for the screws to go in and secure the dividers. So I make big cutouts because the whole encoder goes through here, right, and mounted on the bottom of the top panel. So all encoders, um, the arrows, pad them, right? So you get this. So I didn't bother making the white. These are supposed to be white part, but I'm not doing backlighting, so um, doesn't matter. Just have the lines and the arrows. So then the bottom recess for the toggles, for the parts, then you have the locking hole, right, for the toggles. So you have the top recess, right, just to put the nut, and it will sit flush so that the knobs can sit on top flush, flat, and this is how it looks like. Okay, so whenever you have a big panel and you have a lot of text, um FreeCAD gets sluggish, so you want to pad all this text at the very end after you confirm all the size of the holes, position of everything. Now here, just like the electrical panel, we have this screws, right, go through the back panel, and then at the bottom secure the dividers. And here, this kind of slot means that it's a three-way toggle, and we're done. And we see here the dividers like the electrical panel. Okay, I just noticed I forgot the text of the panel, external, internal lights. Um, doesn't matter. So we are done. Here, the code, right? All the parts change to encoders and all the toggles. Next, we will take a look at the oxygen panel, just flipping it around, see how it moves with the levers. Thank you guys for watching.